All right, we're going to do some conversions with special ratios. So in this first one, we're starting with 275 cubic feet, right? So that's a cube, that's a foot on each side. And we're going to gallons. And at first this seems weird because cubic feet, right, feet measure length and gallons measure volume. And those are different, but a cubic foot is like a box, so you can actually fill a box up with liquid. And we see from our conversion sheet that there are 7.4805 gallons in 1 cubic foot. And therefore, right, that makes your cubic feet go away. I multiply across, and I have 2,057.14 gallons for this particular problem. So it's all about finding the right identity ratio to use. In number 2, I'm doing 25 cubic centimeters to milliliters, or cc's as sometimes they're called. So I notice on my sheet that I have a conversion that is 1 cubic centimeter to 1 milliliter. And so you'll see that cubic centimeter cancel out cubic centimeter. It's just 1. It's a 1-to-1 ratio. So if you have cubic centimeters, that is the same as a milliliter. So if you have a sugar cube that is a box and it's 1 centimeter on each side, that is the same as 1 milliliter in terms of volume. So now we're going to go from 24 cubic feet of water, and how many pounds is that? Well, you can't go from cubic feet to pounds, but you can go from cubic feet, as we know, to gallons. So first we go to gallons. So that makes my cubic feet go away. And I know from my ratio that 1 gallon of water is 8.33 pounds. And you got to make sure here that we're talking about water because different liquids do have different weights. So if I can change cubic feet to gallons and then gallons to these pounds of water, when I multiply straight across because everything's in the numerator, I end up with 1,495.5 pounds of water, H2O. 22. Let's go to gallons to yards cubed. And you might be thinking, I don't understand what's happening. Well, first of all, just start with what you have. I have 150 gallons. What do you know? I mean, we want to end up in something that measures length. Well, I know that 7.4805 gallons is 1 cubic foot, right? We know that. So that at least gets us out of gallons and into something that measures length, because cubic feet measures length. Well, we know how to go from feet to yards, right? 3 feet is a yard. Recall, exponent tells you how many times to do this conversion. 1 yard, 3 feet. Do it again, 1 yard, 3 feet. So I'm going to start with 150. I'm going to divide by 7.4805. These are all in the denominator, so I divide by 3. I divide by 3. I divide by 3. And when I do all that, I end up with 0.743 cubic yards. So not quite a full cubic yard is 150 gallons. Kind of crazy. Title 23. The water in a tub weighs 9 kilograms. How many quarts of water are in this tub? And you're like, what are you talking about? Well, remember that we know how much a gallon of water weighs. So we can go quarts to gallons. We can go kilograms to pounds. So you kind of, again, start with what you're given. I'm given 9 kilograms. Okay, I need to somehow go from kilograms to volume. Well, first of all, let's change kilograms to pounds. I know that 1 pound is 0.4536 kilograms. So that puts me out of kilograms into pounds, and I know that 8.33 pounds of water is equal to a gallon. So now I'm out of pounds and I'm into gallons, and as we all know, 1 gallon is 4 quarts, and that takes me out of gallons. So to do the math, I start with 9. I divide by 0.4536. I divide by 8.33, and then I multiply by 4. And I end up with 9.53 quarts. It's very interesting, right? But start with what you have, and then use conversions of what do you know about kilograms? What can you change to kilograms? How does that guide you? Let step by step guide your process. Number 24 is a multi-step problem here. We have a fish tank that measures 24 inches by 16 inches by 12 inches, and the question is, how many cubic feet will it hold? Well, first things first, I'm given inches. So 24 by 16 by 12 tells me that I have 4,608 cubic inches. But that's not the question. So I have my 4,608 cubic inches, and I know that there are 12 inches in a foot. And I know there are 12 inches in a foot, and I know there are 12 inches in a foot. Notice I did it 3 times because my exponent's a 3 there. So 1, 2, 3. They're all on the bottom, so I divide, and I end up with 2.67 cubic feet. Now that's part A. Part B says, how many gallons will it hold? Well, remember, I have 2.67 cubic feet. Based off our conversion, 1 cubic foot is the same as 7.4805 gallons. So multiply across, and that'll hold 19.97 gallons of water. That's a lot of water. And part C, how much will that weigh? Well, remember, I have 19.97 gallons from part B. And I know that 1 gallon is 8.33 pounds. So gallons cancels out. I multiply across, and that's 166.35 pounds. Boom. That's how much the water weighs. 25. Again, multi-step problem. A small fish tank is 12 centimeters by 10 by 15. Find the volume in cubic centimeters. No problem. I multiply 12 times 10 times 15, and I have a volume of 1,800 cubic centimeters. Well, let's find that in milliliters. Well, recall that 1,800 cubic centimeters, and we have a 1 cubic centimeter to 1 milliliter ratio. So that means I just have 1,800 milliliters. No problem there. I like 1-to-1 ratios. How many liters will this hold? Okay, so if you think about this, I have 1,800 milliliters. When I go, milliliters are over here, meters are here, I have to go left 3 places. So I take my decimal, 1, 2, 3, and I end up with 1.8 liters. Next problem. Why didn't my page flip? There we go. 26. A swimming pool is 30 feet by 20 feet by 4 feet. What is the volume in cubic feet? Well, it appears to be a rectangular. So 30 by 20 by 4, and I end up with 2,400 cubic feet. How many gallons of water will this hold? Well, 2,400 cubic feet from part A. We know that there are 7.4805 gallons per cubic foot. So cubic foot, I multiply straight across, and I end up with 17,953.2 gallons. That's how many gallons of water the pool can hold. 27. Anthony has a giant water balloon that holds 1.5 cubic feet of water. Is Anthony going to be able to pick the balloon off the ground? This is our ultimate question, but we've got to figure out, in order to do that, we got to know how much does it weigh, basically. So if we have 1.5 cubic feet, we're going to answer part A first. How many gallons is that? Well, I know that 1 cubic feet is 7.4805 gallons. So 1.5 cubic feet will be 11.22 gallons. That's a lot of water. And how much will that weigh? Well, if I have 11.22 gallons, and we know that 1 gallon weighs 8.33 pounds, well, that makes the gallons go away. If I multiply, I get 93.46 pounds. If he fills that all the way up, it's going to weigh 93 pounds. Now, Anthony might be a big guy. He might be able to lift 93 pounds. But think about this as a water balloon. Water balloons are, almost like movable. They're not just, it's not a bar. So my answer is, I say no. I don't think he can lift off the ground. Even if he can lift 93 pounds, I think this thing is so giant and so awkward that he can't lift it. That is my conjecture. And last problem, I believe. Yep, last problem. If your swimming pool holds 12,000 gallons of water, how long will it take a 2,000 gallon per hour, that's what that means, GPH, gallon per hour pump, to pump the water out of the pool for the winter? So we start with how many gallons we have, 12,000 gallons. And it says we have 2,000 gallons per is the division bar. So I need the gallons to go on the bottom, 2,000 gallons per hour. And it's okay to write it upside down, right? You put it where you want it. Gallons cancel out. I'm going to divide, and it's going to take 6 hours. And there is the video on special rates.